Hey, in this video, we're going to be doing another concept in context, where we will be looking at the relationships between internal energy, heat, and work. As you may remember, the change in internal energy is equal to the sum of the heat gained or lost by a system and the work done on or by the system. So we're going to do this problem and see how that looks. So let's get right into it. All right, so we've got this problem here. This says a balloon is filled with 39.1 moles of helium. This balloon has a volume of 876 liters. It's held at 0 Celsius and at 1 atmosphere of pressure. The temperature of the balloon is increased to 38 degrees Celsius as it expands to a volume of 998 liters. The pressure remains constant. So we're asked to calculate the heat, the work, and the change in internal energy for the helium in the balloon. And we're given this information. The molar heat capacity for helium gas is 20.8 joules per degree Celsius per mole. All right. So just as I mentioned, the change in internal energy is equal to heat plus work, or Q plus W. I'm going to write that here because that's going to be really important for doing this problem correctly. Not G, but Q plus W. All right. So I also want to mention that Q is related to changes in temperature and work is related to changes in volume. So with those two hints, let's start to work on some of this problem. So we know that we've got a balloon here in state 1, all right, or the initial state. It's got a volume of 876 liters. The temperature is 0 degrees Celsius, and the pressure is kept at 1 atm. We move to state 2. The balloon is a little bit bigger because the volume gets higher, or the volume is larger. So we go to 998 liters. We've got a this final temperature is 38 degrees Celsius, and the pressure remains constant at 1 atm. All right, cool. So we've got a change in volume here. That's going to be used to calculate work, all right? This change in volume. We've got a change in temperature here. That's going to be used to calculate heat. And now what's very interesting is we're given the molar heat capacity. And so we write that heat equation a little bit differently than we would otherwise. We've got our moles, we've got the heat capacity at constant pressure for helium, and then we've got a change in temperature, all right? Our pressure stays the same and it's incorporated into our work equations, all right? So I'm going to write out the full equation for the change in internal energy. That's Q plus W. But what I'm going to do, I'm going to put this in brackets. Q is going to be noted by, or we're going to represent Q with all of the values that we need here. So we've got 39.1 moles of helium, okay? We've got this 20.8 joules per degree Celsius per mole. And then we've got our change in temperature. We're going to do final. Let me write that a bit better. We're going to do final minus initial. All right, that's going to give us our heat value. And then we're going to put in our work value, right? So again, remember, this is work. That's going to be negative 1 atmosphere, atm, times final volume minus initial volume. All right. Now, here, we might think we're finished, but this work value here, as we have it, it doesn't give us this value, this work, the work energy in joules right now. The work energy is in liter atmospheres, right? Those are the units on that. So we're going to have to actually multiply this by the value 101.3 joules per liter atmosphere so that we can turn that to joules, all right? So we have the internal energy, once again, is equal to Q. All right, this is our value for Q, plus W. And this, right above it, is our value for W. All right? So again, what we're going to see here is that Q, right, we see an increase in temperature. So we see an increase in the thermal energy of the system, all right? We see an increase in the volume. That would be an expansion. And with an expansion, we can say that the system did work, right? And that's why we get what you'll see as a negative work value. When we put all this together, I'm actually not sure if the internal energy is going to be positive or negative, but I'll leave that to you guys as something that you can figure out. Because after we've done all this conceptual work, right, and all this mathematical manipulation with the variables and the values, all it is plugging it into a calculator, doing a bit of math, and finding the answer. All right. So this was useful to you guys. I'll see you in another video.